Okay, let's go ahead and get started. Welcome everyone to the Deploying Apps and Microservices with Verrazzano Developer Lab. My name is Tara Van Cleve and I'm a Marketing Event Manager for the Developer Initiative here at Oracle. Today, we're excited to show you how to configure Verrazzano and use it to deploy and manage microservices alongside traditional WebLogic Server applications. If you do not currently have an Oracle Cloud account, we encourage you to create one now. We'll be recording today's session, so if you'd like to follow along with the lab walkthrough and then complete the lab later on at your own pace, we'll be sending the link to the recording in the next couple of days, and it will also be available on the Modern App Dev Series page and Oracle Developer YouTube channel. You'll also have the opportunity to participate in a short quiz on the material covered in today's lab. Upon completing the quiz, you'll receive a Developer Masterclass badge that you can share to your social media, recognizing your commitment and earn expertise. If you have any questions during the lab, please ask them in the Q&A area, and we'll have solutions expert and senior cloud trial representative Cassandra Dickey here to help answer those throughout the session. Today's lab will be presented by Maciej Gryska, and he's the Director of Product Management for WebLogic Server, and Ankit Pandey, the Senior Product Manager for WebLogic Server. So without further ado, I will turn it over to Maciej.
I hope it is. So as it has been introduced, I'm gonna do a short introduction what Verrazzano is, and then I will guide you through the lab content. Generally, I'm gonna give you a demonstration how this laboratory looks like and how you can run it. You may run it in parallel with me. Then if you have any issue or question, then you may ask over the chat. And Ankit, who is gonna serve here as a help, he would be able to answer your questions with respect to the laboratory material. And if you would like to run it later with your own pace, you should be also good, as the session is being recorded and you're gonna get access to the recording later on. Verrazzano itself is an open source platform that Oracle developed recently. It is a container management platform. So it's an open source project that Oracle created for managing containers in Kubernetes. We observe a significant trend that our app dev customers, application development customers are moving into the containers. They're trying to adopt containers for either traditional software like WebLogic or Coherence, or into the new modern application development models like microservices. Verrazzano is being offered in two models, either as a totally free of charge open source software or like a commercial edition with a commercial subscriptions. With the second, we are providing full access to the support, and also we are providing support for different microservices frameworks as part of the platform. So customers that are running the Verrazzano and commercial contract are gaining also access to the commercial support on frameworks like Spring Boot, Micronaut, or Helidon. What Verrazzano lets you to do, first thing that allows you to achieve is allow you to intelligently manage the workload across the environments. So once you deploy the application into the Kubernetes, an application is a composed applications that contains multiple microservices, several different traditional components. So it's like a very complex application. Then you expect that these applications are gonna be somehow bound together through the service mesh and the Kubernetes. So Verrazzano automatically plugs such kind of complex applications into the embedded service mesh of Istio and makes the entire workload runnable and visible to each other. Once you run the applications, We also provide one single application lifecycle management. So it is like a DevOps platform that provides for the applications that are composed and complex single application lifecycle management. What does it really mean? It generally means, imagine that you are deploying like traditional application that has a WebLogic and Java EE pieces, and I don't know, 15 or 20 microservices to that. So that application is like a composed application. It consists of 20 different containers. Then if you want to upgrade the application, you want to upgrade it in a consistent way from one version to another, not necessarily every single component separately. You want to consistently upgrade the entire stack from one consistent state into another one. If you want to shut down the application, then you are shutting down all these containers together. If you want to partially move some application components to another Kubernetes clusters, you're able to do that. You just notify the container management platform, and Verrazzano will automatically make all necessary routing definition changes and the Istio level. Verrazzano provides for such complex applications automated built-in observability. So Verrazzano provisions automatically Prometheus with Grafana, provisions automatically Elastic and automatically binds every deployed applications into the Grafana, into the Elastic Stack. So you are able to manage logs that are coming from different containers and see them in the single place. You are able to make a full 360 degree view on your entire applications through the Grafana dashboards. So built-in observability is like a strong feature of Verrazzano. Verrazzano itself allows you to leverage more than one cluster of Kubernetes. So provide for you also multi-cluster infrastructure management, gives you an ability to deploy these clusters into the different environment of Kubernetes. So you may imagine that you would like to build an infrastructure that span multiple clouds, like, I don't know, Oracle Cloud and Amazon, or Oracle Clouds and Azure, and you would like to run a single container management platform that spans more than one Kubernetes clusters across 2 different cloud providers. Or you would like to define, I would say, multi-cluster strategy with some clusters running on-prem in your own data center and some clusters running in the cloud. Verrazzano is a cross-vendor software, is a vendor-neutral software. So you're gaining ability to deploy the Verrazzano asset platform into the multi-cluster environment across multiple different Kubernetes vendors. Verrazzano is a very cloud-neutral platform. We are not, I would say, only running on Oracle or only running on Oracle versions of Kubernetes on-premise. We are giving customers ability to provide a cross-cloud consistency and get the same experience regardless where you really would like to run. Verrazzano also secures the entire environment, so provides multi-level security, including securing connections, securing intra-application communication. So we are securing a network traffic, we are securing system components, we are securing the application component as a part of the platform. So what we really provision as a part of the platform, we provision several open source tooling that are provision as a kind of curated stack. So we make these components runnable together with some predefined versions and pre-configured communication. So we provision as a part of the platform rancher for infrastructure management. We embed everything into the Istio service mesh. We provision Grafana and Prometheus. We provision Elastic Stack with a Kibana dashboards. We provision Fluentd for log collections. We provision Jaeger. We provision Keycloak. All those components are provisioned as a part of the platform. They are pre-configured, pre-integrated, and every application deployment we do into that platform automatically plugs these applications into these components. So you don't need manually anymore configure log management. You don't need to configure manually integration with Prometheus. You don't need to plug everything manually into Istio. Everything is done for you as a part of the Verrazzano deployment. Verrazzano takes care for traditional applications, so allows you to deploy traditional Java EE, Jakarta EE applications with WebLogic, or traditional applications with Oracle Coherence, or Verrazzano gives you an ability to plug into the platform and manage the platforms with Java microservices. We are very open what kind of Java microservices frameworks you are able to run. As a part of our commercial subscription, we are providing a full support for free frameworks. It's a Helidon framework from Oracle, as a Spring Boot, and it's Micronaut. However, you are also able to plug in any other polyglot microservices, so solutions based on Ruby or based on Node.js or Python or PHP are also pluggable as long as if they run on containers. The platform itself is deployable anywhere where you have Kubernetes. So platform will allow you to run anywhere where Kubernetes runs. So you can run it in any kind of public cloud environments, I don't know, Oracle, Amazon, Azure, Google. You can run it on your Kubernetes on-prem with Oracle PCA or Oracle Linux or any other Kubernetes vendor, and you can mix and match these environments. Kubernetes allows you to run multi-cluster, multi-cloud scenarios, and allows you to run that platform across more than one platform cluster, and allows you to run it in a cross-cluster scenario. So as a summary, what is it? It is a complete opinionated secure container platform that consists of open source components and the different areas like application modeling, traffic routing, observability, cluster management, and security. We are adding to that several our own open source custom resources and controllers. And we are building out of that like a curated and integrated platform to each other. With a commercial edition, we provide a support for Java framework, like Helidon, Micronaut, and Spring Boot. And we are providing also with a commercial edition data state management platform with a coherence entitlements. We try to simplify and automate rapid movement of traditional applications of Oracle application server of WebLogic into the Kubernetes. So we somehow automate the movement of traditional applications into the platform. We focus a lot on a simplification of process of converting traditional applications into that, but we also provide a full support for microservices. We run it in the multi-cluster and multi-cloud and a totally cloud neutral environment. So it's not Verrazzano is not just Oracle Cloud solution. It can run in any cloud, anywhere where you have a Kubernetes. We are supporting for describing application a new way of, let's say, defining applications. There is a specification driven by Microsoft and Alibaba. Oracle participates in the community since that summer. And we allow customers to leverage that specification to describe applicational components that are deployable into the platform. So we are using that specification, and that through that specifications, customers are able to describe components of the application and pass to the Verrazzano, and Verrazzano takes it, introspects the configuration, and takes all necessary containers and deploy it to the proper Kubernetes platform. Today, during the demo, during the laboratory, we will be using the Oracle Cloud. We will be using two services of that cloud. We'll be using Kubernetes platform, Kubernetes service. It is official name is Oracle Container. Oh, it's OKE is acronym. I even forgotten the name. It's a managed Kubernetes service in Oracle Cloud, and we will be using a container registry for storing the images that we will be building during the lab. Please have a look into the laboratory guide link and live lab link. I believe Tara placed the links into the chat, so that you can refer to the chat to the link. This is what we will be using today. Have in mind that the reason why we are using Oracle Cloud is only because it's easier for us to provision for you the Kubernetes clusters to the Oracle Cloud, and easier for us to produce tutorial based on the screenshots from Oracle Cloud. But the same set of labs and the same set of exercises you can perform on top of Verrazzano, running on top of any Kubernetes cluster. So if you decide to try to replicate it with Kubernetes on-premise or Kubernetes running in any third-party cloud, the laboratory scenario and set of actions would be absolutely the same. So having said that, I will jump into the laboratory right now. This is the lab guide link that we'll be following today. Laboratory consists of 8 separate laboratories. So what we will be doing today, we'll be first doing the installation. So to install Verrazzano, we need to have a Kubernetes engine set up. So we need to set up Kubernetes cluster. This is the first thing that we will be doing. Then you will be performing installation of Verrazzano. Then you will deploy some sample application. I will talk about that applications when we go to the laboratory free. Then we will access that application and we'll check that application is properly running. And we will explore several consoles. Then we will try to check how the lifecycle management looks like. So what's going on, what steps are necessary if I want to modify some components of the application. Application itself will consist of, I don't know, 3 WebLogic domains, 2 coherence clusters, and 4 different microservices. We'll be modifying microservices today. We will show you how to modify the microservices, how to make changes, how to push how to generate a container image, how to push the image, and how to notify Verrazzano that there is a new image, in the repository. So we will modify the OAM file, OAM definition. And Verrazzano should pick up the changes, should automatically terminate the old version of container, start new version of container, and should plug automatically this new microservice into entire observability stack and into entire platform, and plug it properly into the Istio service mesh. So this is what we will be testing at the end. If after making changes, entire communication is running properly. Okay, so let's jump into the lab. The first thing what you need to do is you need to log into your cloud account. This is a OCI Cloud Console. So to install and create a Kubernetes clusters in Oracle Cloud, you need to open that hamburger menu, and you would need to find developer services. You need to select Kubernetes clusters. You need to select, I'm not sure if I'm in the proper, or I'm not in proper, sorry, in the proper region, because I need to jump into the region where I want to be. And you need to select your compartment if you have compartment. In my case, it's Ankit compartment. And here you have a possibility to create a cluster. This entire flow of logic also is described here as a task 1 in your lab tutorial. So lab tutorial shows you exactly step by step, screenshot by screenshot, what you have to do. So again, it's a hamburger menu, developer services, Kubernetes clusters, selecting compartment, and there is a create cluster button. So if you create a cluster, you have 2 options, either quick create or custom create. For purpose of that lab, it's fine if you go with a quick create. So you need to launch a cluster. You need to select a name. Default name is fine. You need to select compartment. You need to select a version. Leave all this by default. Then there is a question where to, how would you like to have an access to Kubernetes API endpoint, or you would like to make it private? Default option is public endpoint, and this is the recommended way to do. And also there is a question what to do with a worker nodes. Should they be private or public? And private workers is fine. So default option is okay. The only place where you need to pay attention is about shape. By default, the recommended shape is too small to handle entire observability stack and handle full application sample that we were intend to deploy. So you need to go to the drop-down list and look for a shape that we recommend into tutorial. It's a vm.standard.e2.4. This is a shape we recommend in the tutorial, and we recommend to put 3 nodes. So the region that you will be deploying is going to have 3 availability domains, and by default, Kubernetes cluster is going to be spreaded with 1 node across every availability domain. Then you should press next. That's like a summary page. And then if you click a create cluster on that page, the workflow for cluster creation will start. And that's generally end of creation of the cluster. It takes roughly 7 minutes to make cluster active. So to make cluster master nodes available. I'm not gonna do that because we are not gonna wait the 7 minutes here. I will use a cluster that we pre-created for this environment. So once you click create cluster on the previous screen, you move more or less to that page, but that icon will be like a yellow icon saying preparing or creating. So this icon will, you need to wait for 7 minutes to turn it to green. And the tutorial also shows exactly this process. So the process is saying, I don't know, someone is slacking me. So if you click create a button, then originally this icon will be yellow. After 7 minutes, the status of the cluster will change from creating into the active. Generally, active cluster means that the master nodes are available, and the master nodes are enough to start further laboratory. It will take 5 or 6 more minutes before nodes are available. You may observe them in the node pools. So there should be one node pool called pool 1, and in the pool you should see that there are 3 nodes that are about to be created. Ready generally means that they are already available. So as I said, 7 minutes to wait for this active cluster. If you are right now doing the lab, yeah, please follow and wait the 7 minutes. And those of you who are just watching it as a demo, I will show you what you need to do to access the cluster. We will be using during the entire set of laboratory Kubernetes command line interface. It is called kubectl. The kubectl is like a command line interface from the terminal. The kubectl, we will execute it in the Cloud Shell environment. Cloud Shell environment is like a terminal over the browser running in the cloud. So what you need to do is you need to click that icon, start a Cloud Shell, and when your cluster is active, you need to create access cluster, and you need to download the kubeconfig file. When kubeconfig file, to download kubeconfig file, you need to just copy that instruction and execute that instruction inside the Cloud Shell. That generally makes kubectl, available here. So if I can check the nodes, then you see that I can get and reach that Kubernetes API server and collect information that there are 3 nodes up and running. So generally, these steps are necessary to execute creation of the cluster and access that clusters over the kubectl interface, but generally it's the end of laboratory 1. So laboratory 1 is creation of a cluster and configuring kubectl Kubernetes command line interface and the Cloud Shell environments. When this is ready, you would be asked to install Verrazzano. Installation of Verrazzano is split into 2 steps. The first step is the installation of platform operator. Platform operator is a component that controls if Verrazzano itself is properly running with all containers properly configured. Verrazzano itself is implemented also as a containerized application. And there are several containers that are being provisioned, and operator verifies that these containers are properly in the running state all the time. So to install Verrazzano operator, you need to follow task 1. Generally, you would need to execute that instruction. So kubectl apply and YAML that describes the operator is provided here. Once you execute that, you are able to verify if the operator is properly installed by executing this command. I have run it in advance, so I'm just gonna show you that in my environment, rollout has been done properly. So operator is really running properly. So I have in my cluster already Verrazzano platform operator up and running. And you are able also to verify if the Verrazzano platform operator is running as a pod by executing that command. So in my case, 7 days ago, when we were preparing the first dry run for that lab today, we installed platform operator, and it is still running. It didn't restart in the meantime. So the second task is installation of Verrazzano itself. Verrazzano is being shipped with several profiles. We have either production profile or development profile, or we have a multi-cluster profile. In a case of multi-cluster, you're just installing, we have a concept of admin cluster and concept of managed clusters in that case. So in the concept of multi-cluster installation, there is a different set of components you're installing on the managed cluster and different set of the components you're installing on the master clusters. For simplicity of the environment, we would be installing here development profile. Development profile is not having any persistent storage and is using just a single node Elasticsearch instance. To install, this is a very simple installation process. Just to install the Verrazzano installation process, you need to apply the following YAML document to the Kubernetes. It's a custom resource object of type Verrazzano and provides you the name of the profile that you want to deploy. In my case, it's a development profile. It would be a development profile. An operator of Verrazzano looks into that custom resource object. When it's recognized you created that request, the operator will automatically install all necessary components, and operator will perform entire installation for you. An operator will check and verify that all the time, all the components are in the proper state. So if any of them would fail or in any of them would get misconfigured, operator will automatically provide correction for you and will reconfigure the entire platform for you. Installation of Verrazzano with development profile takes between 15 to 17 minutes, depending on the cluster configuration, because there are several containers that needs to be downloaded with Grafana, with Istio, with Prometheus, with Kibana, with Elasticsearch. So several images needs to be downloaded. All of them needs to be started. All of them needs to be configured to work together. So it takes time. To save a time on our demo, we have already installed the Verrazzano. So we have executed that command in advance. So that command was executed in advance. So right now, I'm only going to show you the status that Verrazzano is properly installed. So I just copied that instruction. execute that. And it should show you that installation of Verrazzano conditions were met. So install complete status has been achieved and Verrazzano is in a proper shape. Right now, to verify if Verrazzano is also properly installed, you have an ability to check if all the pods are in the running state. So if I copy this command, you're able to take and verify that Verrazzano is properly installed. As you can see, there are, I don't know, several pods with containers running that are responsible for different aspects of Verrazzano. There are also containers with Grafana, with Kibana, with Prometheus, with Rancher, with FluentD. Some operators are automatically pre-configured, runtime for open application model. So all of them that are composing a Verrazzano platform are created here. That somehow finishes the lab 2. As I said, installation of Verrazzano takes between 15 to 17 minutes, and to save a time during the demo, we have done it in advance. But if you would be doing it yourself, this step will take you roughly 15 to 17 minutes. So going to the lab 3, we will be deploying to the Verrazzano Bob's Book application. Bob's Book application is one of the samples that is being shipped with Verrazzano. There are several samples that we are shipping, starting from very basic Hello World microservice applications to more complex applications. The Bob's Book seems to be one of the most complex applications that we are shipping, but it's giving you quite good visibility how these applications are being deployed and what they are composing of on traditional Verrazzano applications. So this application will have 2 WebLogic domains. So imagine that we have like we are in the books business. So we are selling books over internet, and we have two e-shops, one with a book for adults that we call Bob's Robert's book, and there's another like daughter company that we created that is focusing on selling book for kids, and this is called Bobby's Book. And architecture of the electronic shops that we have built are different. We have one back office application that is responsible for transaction on database. It's a WebLogic application that is talking to a database. In our case, for simplicity, we are using MySQL, but it could be any other database. And the Robert book application is using a coherence and memory data cache data grid component and 2 microservices, one for order management, one for tracking API, and there is a UI reactive applications also deployed. So this is a Robert application, it's totally microservice. And we have a Bobby's Book that is having a front end built with Java Server Faces UI on WebLogic that talks to the order API as a microservice on Halon, and stock application that is talking to another microservice that talks to the coherence that is responsible for keeping the stock information in memory. So that's like a artificial maybe architecture, but architecture somehow tries to shows you as example ability to run really complex and composed applications. So we will be deploying these applications onto Verrazzano. To take care for deployment of this application, there will be several tasks that you need to perform. The first task that you would need to perform is you would be installing in your trial account several licensable components. So first thing, what you would need to do, you would need to accept the licenses. So you need to log into the container registry. That's that page. Extend. I hope I will catch this. And what you would need to log in is you need to find the Verrazzano containers and Oracle Container Registry. And there are several licenses attached to the example containers. So Coherence and WebLogic are licensable software, and generally you need to accept the license. So you would need to accept the license for all those components. I think there are four licenses you need to accept. Once you accept the license, generally using your credentials, you'd be able to download the containers from Container Registry. That's only for the legal purpose. That means licensable software requires users to accept the license. And once the license is accepted, this containers would be able to be downloaded with my credentials. By the way, if you have any questions, the interaction that we may provide to you is through the Q&A or through the chat functionality. Ankit is working here, so Ankit would be able to provide you answers for your questions over Q&A functionality. So I hope you'd be able to at least start some part of your labs. Okay, once the licenses are accepted, then the next thing what you need to do is to deploy the Bob's Book application. To deploy Bob's Book application, you need to download two YAML files. This instruction allows you to download two YAML files that represents OAM component and Verrazzano configuration file for deployment. Because the access to, we will also create a separate namespace for this application, and this namespace would need to be labeled that it's going to be managed by Verrazzano, and Istio will be automatically injected into this namespace. I can show you and verify that this namespace has been created in advance in my environment. So you see that there is Bob's Book, Bob Books namespace already created in advance to my Verrazzano, to my lab environment. The next thing what you need to do, you would need to create a secret that contains username and password that you use to log into your container registry. This is only for the legal purposes because this example is using WebLogic and Coherence. So we need to know that the user that is downloading the images accepted licenses. And so this script will automatically create for you a secret. So generally, we are trying to log you in to the environment, and if the username and password you provided, fine, we will create a secret in the environment. And the last thing what you need to do is to generate some credentials. We cannot hard code the passwords into any scripts. So we generate randomly credentials, we storing them as a secrets. And once all this preparation is done, we just basically apply the YAML file with components and YAML file with the applications. And it takes some time, maybe 5 to 7 minutes. to verify that the containers are ready. And after 5-7 minutes, your application will be up and running. Again, I wanted to avoid this 5 minutes waiting here. I have pre-created environment already. So my kubectl get pods from namespace Bob's books will show you that in my environment, all the containers are already up and running. So entire application that consists multiple coherence containers, multiple Helidon containers, several WebLogic servers and domains, in this particular example too, with admin and managed servers are up and running and they are serving application. My application is up and running here, so I can show you that this is a Roberts book. So this microservice application that's responsible for selling books for adults. So I can go, I can navigate, I can check, I can add to cart, I can buy. And there is also another bookstore application for Bobby's books. This one includes the books for kids. I don't know, maybe Angels and Demons is not the best good book for kids, but maybe To Kill a Mockingbird might be a good one. So I can go, I can add to the cart, I can do a checkout. It's a simple application. So we don't do any credit card or nothing. I don't know. Test user that is buying from some street in city Los Angeles and state California. And when I submit an order, my WebLogic application will send it to the order management application that is like a Helidon application that will forward to the WebLogic that is on the backend and will make the entry on the order database. And then there is order manager application. If I somehow refresh it, then I can see that today test user from LA just order some books. So this is example that is up and running. Also, we have a Verrazzano console that I have started already. We can navigate and verify that application is deployed. We can navigate and check what kind of components are available here. And the component that we'll be using today and we'll be touching today is a Bobby Helidon application. So if I go to the Bobby Helidon application component, I can navigate. So if I go to components, if I go to Helidon, Bobby Helidon application, and if I choose a workload specification for that, I can verify that this is being running based on that image. So we are downloading image from the container registry.oracle.com. Have a look into that configuration or parameter, because this is the one that we will be changing and modifying once we update the application. Also, if we go to the home, we can potentially start any observability stack. So we can start, for example, Grafana. We can navigate through the different dashboards that are giving you a view on different components. Like, I don't know, you can navigate to WebLogic dashboard, see which servers are up and running. There is only one managed server, containers, components, applications. If you come back to the home, and you go to the Helidon monitoring dashboard, you can see different Helidon applications that are right now runnable. Our Bobby's Helidon application has an uptime like 12 hours. It's up and running. again, we can verify people that are working with Grafana, they are using for a daily basis. So automatically, Verrazzano gives you an full view into the applications through the Grafana dashboard. That practically covers the lab 4. So lab 4 was about accessing the Bob's book sample and exploring Verrazzano and Grafana console. So let's look if everything is set up in your environment, everything is configured. Let's try to make the modification. So we will modify Bobby's Helidon stock applications. So if we come back to this Bob's books examples, we will modify this application that talks to the coherence cluster on the backend. So we will try to make changes. This application is responsible for displaying what is available on a stock on UI. So UI is asking this application, give me access what is available right now on our bookstore, and stock application is serving that information. So we will make these changes. What kind of changes we will do? Bobby's book application, whenever we display books, and when you get into detail of books, for example, Harry Potter, displays this information. Yes, it's available. You can add to the cart. This is a title. This is the offer. So we will make some kind of insignificant change. We just generally try to change this title into the uppercase. So it's going to be a significant change on one hand, but also visible on UI. So you'll be able easy to verify that Verrazzano picked up the changes. So, so what we should do, we need to modify Helidon's application. So to modify the Helidon applications, we need to download the sources. To download the sources, you need to clone the repository. So we will clone the repository. With sources. We have right now sources in our Cloud Shell environment. And then inside the Cloud Shell, we can check what is there. We can verify if the applications has been already downloaded with all sources. Yeah, so we have different sources for different components right now available. And we will go to and make the change. So there is we need to navigate to the proper file and execute it and VI and edit the sources. I'm on line 84, so I'm in the right line. So I will generally put a single modification into the source. So we will generally on the result set that has been returned from the coherence, we will change the title and we will make the title to the old word name of the title, but we modify it to the uppercase. So if you go and insert here, so I entered one additional line to the source. So right now, Helidon application is supposed to modify all titles and to be an uppercase titles. So I will save it. The next thing what you need to do is create the image. To create image, you need to compile first the application. This application was depending on some coherence applications. So first thing what you need to do is locally have a compiled version of the coherence application. I believe in the proper POM XML, this dependency could be better described. So we are doing it manually anyhow. So I'm compiling first the coherence application, but this Helidon application is using. I'm compiling also my modified microservice application. So right now I have application compiled. I need to start preparing an image with this application. The image will contain the JDK. Our Docker files that we are using a specific JDK version. So I need to download the JDK itself locally. So I'm downloading JDK. So I have a source of the app. I have a compiled version of the app. I have JDK locally. I would be okay to create image. To create image, you would need to navigate locally to verify what's your tenancy name, what's your endpoint for region. Are you in Osborne? Are you in Phoenix? There are several steps you need to execute to verify what would be the name of the image. First, I did all the steps, and I can use some cheat sheet document from my location, and I will generally build a command line already. I have it here. Okay, I copy my command line for building image. Okay, so I was able to create, in your case, because I was doing it already a few times. So as you see, image is using several cached images. So it was pretty fast. In your case, it might take a little bit longer here. I didn't clear a cache before running this lab. That's why this step was so fast. In your case, it may take 2 to 3 minutes to build an image. The next things what I need to do, I need to authorize myself in the repository. So I need to execute the process of pushing image to the Oracle Container Cloud repository. So I need to log in to my repository. Before I will do that, instruction tells us that we need to generate authentication token. Authentication token is like a password that you'd be using to authorize in the Docker interface for your container registry. So I need to move my Zoom. Okay, so out. Oh, sorry. User, where is user settings? If you scroll down, there is authorization tokens. You should be good to generate new token. Oh. If you generate a token, what you need to do, number of tokens is exceeded. So in your case, it will, I already have all possible tokens created. So if you run this, then generally it will display you such page. It will generate a token. What you need to do is to copy a token to your clipboard, because once it is generated, this is the last moment where we display. For the security reason, we don't display it anymore. So even we don't deploy it by default, but so you need to copy it. So the next thing you need to do is you need to log into to your region. In my case is Ashburn region. So I will use the interface of Docker login ID ocir.io. System recognize my username, but I'm using right now. It's okay. I'm good with this username. And I will use my authentication token, but I have pre-created before. For security reason, I'm not going to display it here. Once again, paste. Once again, probably I pasted twice. Okay, login succeeded. So I was I properly logged in to the environment. So I can right now go back in a history, and I can, instead of building, I can push that image into the repository. Okay, I was able to push it. System was able to recognize that some layers are exactly the same as with my cache example. And you may go and navigate to the developer services container registry and verify if your image is there. Oh, you can see image held on stock application is there. The last push happened a few seconds ago. So that's exactly the image that I have just created. So we modify the app, we compile the app, we created image, we pushed the image to the repository. The only thing that is missing, and it is described in the lab 7, is modify application configuration. So application configuration file were downloaded to the main folder. You can see them. So component file is the one that you need to modify. So I need to vi bob component YAML. And I have, and I need, oh, is it? Is it the AMKit? Is it the file I need to modify?
Yes, Magic.
So why is the file already modified?
You can just change the name to the IAD. Everything else will be the same.
Okay. Well, this is you were doing this modification probably.
Yes, Magic.
Is it the same?
Yes, Magic.
Yeah. Okay. So this is the image that I will need to do, and I need to apply it. Oh, sorry, kubectl apply. As you see, when we deploy the application to Verrazzano recognized that only one component has been changed. It's a Bobby's Halidon. So if we right now try to get pods from the namespace Bob's books, we should see that the old version of Helidon, Bobby's Helidon application, is right now in terminating state. But 22 seconds ago, Verrazzano started already for us new version of the Helidon application with the Bobby's book. So if everything is correct and change happen, then on this Bobby's book examples, we should be able to see, if we go to books and we select any of the book, we should see the title coming with the uppercase. So if we select the Harry Potter book, we should see right now also uppercase title. So that is proof that the change that we have performed with lab 5 to 7 really had happened, and Verrazzano under the cover replaced all the containers into the new containers and make the workload running, make the workload running with the new containers. And also, if you go to Verrazzano console, and right now go to the components, and go to the Bobby's Helidon application, and you go and look into the specification of that component, you see previously it was a container registry image. Right now, it's your local image from your OCIR. So it really is proof, but Verrazzano started application with the new image. And also, if you go to the Grafana, and you open the Helidon monitoring dashboard, you should see 2 instances right now, the old one and the new one. And the new one has been started, I don't know, 26 seconds ago when we collected the results. I think when I refresh it, it's gonna be, because it is collected with some intervals. So you have a new version of Helidon containers also being monitored by the Grafana dashboard as a part of the environment. And this is, to be honest, oh, I need to move this zoom control again. This is what is in the lab 8. So lab 8 is exactly about verifying the changes in the Bobby's book application. For those of you who would be running the laboratories and who prefer not to touch the source code and who are not very, I would say, oriented in the code, we prepared also alternate version with a simplified solution for the labs 5 and 7. In this version, you are just downloading the modified YAML file. So you are not compiling applications, you are not building image, you are not pushing image, you are just downloading the application, just downloading the component file and apply the changes to the kubectl. Once you apply the changes to kubectl, then the only change is really on the Bobby Helidon configuration. So you are able to see that Verrazzano is making a change in the application, and lab 8 you are able to perform normally. So you are able to verify changes in the Bobby's book applications. You're able to verify the changes in the Verrazzano console and verify the changes in the Grafana console. If you requested cloud trial today, then basically you have like a 30 days to complete the labs. And I hope this overview was interesting to you. And with this overview, you'd be able to really follow these instructions easier, and you'd be able to complete the labs that is focusing to show you how to build, deploy applications, and monitor, manage the life cycle of the applications built with microservices inside Verrazzano platform on top of Kubernetes. Having said that, that's all from more or less my side. I'm happy to jump into any unanswered question.
All right, thanks so much, Maciek, for the fantastic presentation. We do have some additional resources we'd like to share with you. The first is, if you enjoyed today's session, we'd like to invite you to join us on November 3rd for our next lab in the series, where you'll learn how to create a shopping cart app in 60 minutes with Apex. And then we also encourage you to share with us any feedback you have on today's session or what you'd like to see from us going forward. So we'd like to test your knowledge on what you learned today, and by completing several questions of our lab quiz correctly, you'll achieve a social badge which you can share on your social media. And then lastly, we'd like to mention that Oracle University is now offering free access to OCI training, including free certification exams through December 31st of this year.
I just would like to say thank you very much for staying with us today, and I hope you enjoyed, and I hope you'll be able to test and verify the Verrazzano. If you'd have any questions, technical questions, you may reach me or Ankit directly by email.
Great. So if there are no more questions, I'd like to thank you both again for this great presentation, and everyone for spending your time here with us today. And just a reminder, the recording of the workshop will be available on the Masterclass event page, and then we'll also be sending that out to your email in the next couple of days. So with that, I will go ahead and end today's session. Have a great day, and we hope to see you again next time.